Equilibrium constant K is the ratio of products to reactants at equilibrium. K is products over reactants, so to calculate K, we're going to put the equilibrium concentration of the products over the equilibrium concentration of the reactants, raised to their respective coefficients from the balanced equation. We can also use K equals products over reactants with partial pressures when the reactants and products are gases. So the equilibrium pressure of the products over the equilibrium pressure of the reactants, raised to their respective coefficients from the balanced equation. Now, because K is products over reactants, when K is large, that means there are more products at equilibrium, and the reaction lies to the right. When K is small, that means that there are more reactants at equilibrium, and the reaction lies to the left. So when we calculate K, it tells us which direction the reaction lies at equilibrium. Now keep in mind that aqueous solutions affect concentration, and the partial pressure of gases affect the total pressure. But solids and liquids don't affect equilibrium because their concentration remains constant. So we're going to omit solids and liquids from our equilibrium expression by crossing them out and replacing them with a 1. The last thing I want to talk about with K is when it changes. So no matter what changes occur during a reaction, such as adding more products or adding more reactants or removing products or reactants, K doesn't change. So if your reaction lies to the right, meaning there's more products at equilibrium, then it will still lie to the right even if you make changes to the system. If you think back to our straw lab, our reaction lied to the right, so there were more products than reactants when we reached equilibrium the first time. Then we changed the system by adding more products, and equilibrium shifted to the left by making more reactants. But there were still more products than reactants when we re-established equilibrium that second time, which means the reaction still lied to the right. Now there is one exception to that rule. The only thing that changes K is temperature. If the temperature changes, that could change the direction equilibrium lies. So we could change from having more products at equilibrium to having more reactants at equilibrium, or vice versa. But when anything else is changed besides temperature, K doesn't change. In the first example for the decomposition of hydrogen iodide, the equilibrium concentrations of all the reactants and products are given, and we're being asked to calculate the equilibrium constant K. K equals products over reactants, so we'll put the concentration of our products over the concentration of our reactants. And don't forget, we need to raise the concentrations to their coefficients in the balanced equation. In the second example, for the decomposition of nitrogen dioxide, the partial pressures of all the reactants and products are given, and we are being asked to calculate the equilibrium constant K for pressure. K equals products over reactants, so we'll put the pressure of our products over the pressure of our reactant, raised to their respective coefficients.